All right, good everyone. You're welcome to this class. So today I will talk about matrices. So how do we handle matrices in Python? And we'll also look at some of the applications of matrices to solving certain problems. Okay, so a matrix is a two-dimensional data structure where we arrange numbers into rows and columns. Okay, so the rows are, for example, if you look at this matrix, we have two rows. So this is the first row, this is the second row, and there are three columns. So first column, second column, and third column. So how do we write matrices in Python? So in Python, the best way to write matrices is to use the matrix function in NumPy. So let's say from NumPy, import matrix. So you can also use array, but I think I prefer using the matrix function. So let's say A equals matrix. Then, so matrix, if you want to enter matrix in Python, you enter it as a list of a list. You know, in our previous class, we have learned how to create a list. So we created a list 2, 4, 6, 8, 9, and so on. So this is a list. Okay, so when you now have list of a list, okay, so that is a matrix. So for example, so you now have another list. So for example, if I want to enter this matrix 1, 4, 5, so this is the first row. The 1, 4, 5 is the first row. So that is what I enter first. So I create another list. So 1, 4, 5. That's the first row. Then the second row is minus 5, 8, 9. So another list, minus 5, 8, 9. So this is how I create a list. So I can now say print A. So it will now print the matrix A. So 1, 4, 5 minus 5, 8, 9. Let me increase. So 1, 4, 5 minus 5, 8, 9. So that's the matrix. Okay, that's a matrix. Now, I strongly encourage you to use either the matrix to create the matrix, a matrix in Python, or use array. Please do not use list of a list only. That is creating a matrix using just this. So if you create, let's say B equals this. This is a list of a list. So if you print B, you get this list of it. So it's a matrix, but you will not be able to carry out many of the matrix operation on it. So it's the best. What I recommend is for you to use the matrix function or the array function. Okay. Now when we looked at list, so we said let me use LT. So if you want to access this 5, okay, this 5, you want to access this 5. So you say print LT of what? Of 1. Okay, print LT of 1. So it will give us 5. If you want to access 9, you say print LT of this is 0, 1, 2, 3, 4. So you say print LT of what? Of 4. So to give us 9. This is 9. Now, what if you have a matrix, this matrix A, and you want to access the elements of the matrix? Let's say we want to access 8. This 8. How do we access it? So you know this is 2 dimension, not 1 dimension again. So you have to consider the row and the column. So what row is 8 in? This is the first row. 8 is in the second row. Okay, but second row in Python is what? That is 1. So if you want to access this 8, you say A. So the second row, which is 1, comma, then second column as well. Second column, which is 1. So if you print A11, it will give you 8, which is okay, the element 8. What if you want to access this 5? So we are in the first row, so 0, and what column? The third column, which is what? Which is 2. So if you print, it will give you 5. So this is how you access a 2-dimensional array in Python. If it is 3-dimensional, then you add another, because you can also create a 3-dimensional array. Okay, instead of a matrix which is 2-dimensional, you can create a 3-dimensional, 4-dimensional, 5-dimensional, and so on and so forth. So that's about that. Then matrix operations. Matrix operation. So let's say this is matrix A, and let me create another matrix B. Matrix B. Let's say B is 11, 0 minus 8 3 2 and 19. So we can add the two matrices. So we can say print addition of A and B equals, you could just say A plus B. Okay, since you are using either matrix or array, so if you have used matrix here or you write array, so you can just add, you can just sum the two matrices and you get the correct answer, because it will be 11 plus 1, which is 12, 4 plus 0, which is 4, 5 plus minus 8, which is minus 3, minus 5 plus 3 minus 2, 8 plus 2 10, and 9 plus 19 28. You can also subtract, maybe B from A or A from B. So let's say A minus B equals A minus B. So this is the answer. It will be 1 minus 11 minus 10 and so on. But of course, if you are adding or subtracting two matrices, you must make sure that the dimensions of the two matrices are the same. For example, this matrix A is 2 by 3, that is 2 rows and 3 columns. So this matrix B must also be 2 rows and 3 columns, so 2 by 3. So matrix A is a 2 by 3 matrix, matrix B is also a 2 by 3 matrix. So otherwise, if matrix B, let's try that. Let's comment this out. So let's create a 2 by 2 matrix of B and let's add A and B. So you get error. Okay, so you can say operands could not be broadcast together with shapes 2, 3 and 2, 2. So the first one is 2, 3, that is 2 by 3 matrix, while the second one is a 2 by 2 matrix. So when you get this type of error, it means there is the dimensions of your matrix, of the two matrices, they are not compatible. Okay. Ctrl Z, Ctrl Z, Ctrl Z, Ctrl Z, Ctrl Z. So that's how you add and subtract two matrices. Now, what if you want to multiply the two matrices? Now, we cannot multiply these two matrices A and B. Why? This is from basic mathematics, 100 level mathematics. So if you have matrix A, it's 2, let's say 3, 5, 1, that is A, and matrix B equals 6, 2, 3, 1, 4, 1. This matrix A is 2 by 2. Matrix B is what? 2 rows and what? 3 columns. Now, if you want to multiply these two matrices, you get a result. It's possible for you to multiply them, but it's not possible for you to add them. Now, if these two, the last number here, which is the column, is the same as the first here, which is the row, it means the two matrices can be multiplied. You can multiply these two matrices. But the example we had, okay, we wrote a 2 by 2 matrix. So we wrote 2 by 3, and we are now multiplying by another 2 by 3. This is 3 and this is what? 2. So they are not compatible. So you cannot multiply a 2 by 3 matrix with another 2 by 3 matrix. No, it's not possible. But you can multiply a 3. So this is, let me use red. This is not possible. Okay, this is possible. Let me go back to black. But if you have 3 by 2 and 2 by 3, then this is also what? This is also possible. Okay, so because these two and these two, they are what? They are the same. But in this case, the reason why this is not possible is because this one is 3 and this is what? This is 2. So it's not possible. Now, then you can also use this to know the type of matrix that we produced. If you multiply a 2 by 2 matrix by a 2 by 3 matrix, at the end of the day, you are going to get what? A 2 by 3 matrix, because it will remain these two. So these two will assimilate one another, then you'll be left with 2 and what? And 3. So this will give a 2 by 3 matrix. But okay, we said this one is not possible. So this is not possible. But this one, 3 by 2 multiplied by 2 by 3, you are going to get, so these 2 and 2 will assimilate, then you'll be left with 3 and what? And 3. So this is going to produce a 3 by 3 matrix. This is basic mathematics. Okay. So to teach how to multiply two matrices, so let me modify this 2. So let me say this is a 3 by 3. Okay, so let me create another. So, or let me use this 2 by 2. Then this also 2 by 2. 2 by 2. Okay. We now say A times B. A times B. Now, so how do we multiply two matrices in Python? So what we do is we use, there are many ways actually. So I think the simplest is to say from numpy import dots. So if you import dots, then you can use dots. So we say dot A comma B, that is A times B. Okay, A comma B. Okay, and that is 23 9 minus 31 11. Sorry, let me remove this one. Let me use simple numbers so that we can test. Okay, so so if you have the first matrix is 1 4 minus 5 3, 1 4 minus 5 3. So 1 4 minus minus 5 3. I want to multiply with 2 1 3 2, 2 1 3 2, 2 1 3 2. So what we do is you take this, you multiply it with this. So you have 1 times 4, 1 times 2, which is 2, plus 4 times 3, which is 12. Then this again multiplied by this column. So 1 times 1 1, plus 4 times 2 8. Then minus 5 times 2. So this again multiplied by this and this. Minus 5 times 2 minus 10. Then 3 times 3 9. Then minus 5 times 1 minus 5. 3 times 2 6. So that this will be 14 9. This is minus 10, right? That will be minus 1, then 1. So minus 14 9, minus 14 9 minus 1 1. So 14 9 minus 1 1. Yeah, so 14 9 minus 1 1. So that is the correct answer. So that's how you do multiplication of matrices. Of course, this can be 10 by 10 matrix. So that's the beauty of the numpy dots. Even if you have 100 by 100 matrix, multiplying by another 100 by 100 matrix, so you easily get the answer. Okay, so we have learnt about addition of two matrices, subtraction of two matrices, and as well as the multiplication of two matrices. So next is the transpose of a matrix. So let's say we have this matrix A. So let's print A. So we have 1 4 minus 5 3. I want to print the transpose. So we say print the transpose. The transpose of A is, so if you want to print transpose, just say A dot transpose. A dot transpose. That's all. A dot transpose. Okay. Transpose. Yeah. Transpose, the spelling. So TRANSPOSE. So the transpose will be 1 minus 5 4 3. I believe you know what is a transpose. So if you have a matrix like we have 1 4 1 4, let's say 3 6, and you want to find the transpose. So the transpose, if this is A, the transpose of A is you change row to column. So it will be 1. So this row will not turn to column. So 1 4. Then this row would also turn to column 3 6. Okay, that is the transpose. So in Python, so if you want to do that, you just say A dot the matrix dot transpose. Then you put open bracket and close the bracket. Okay, so that's how you find the transpose of a matrix. So next is the determinant of a matrix. The determinant of a matrix. How do you find the determinant of a matrix? So this matrix A is 1 4 minus 5 3. So the determinant of a matrix 1 4 minus 5 3. So let's say A equals 1 4 minus 5 3. So the determinant of A is you multiply this 1 by 3. So 1 times 3. then minus 4 times minus 5. 4 times minus 5. So that would be 1 times 3 is 3. 4 times minus 5 minus 20. Minus times minus, that is plus. So that would be 23. So if you want to do that in Python, you say from numpy dot lin algebra import determinant det. So you now say print the determinant of a is comma dit a. Determinant of a is dit a. Okay, and which is, I think that's what we got, 23. Okay, determinant of a is 23. So we have learned addition of two matrices, subtraction of two matrices, multiplication of two matrices, the transpose of a matrix, the determinant of a matrix. So I think next is the inverse of a matrix first before. So for the inverse, we also import it from numpy.linear algebra. So this linear algebra package is a very, very good package for anything that has to do with matrices, matrix operations. So what is the inverse of a matrix? If you have a matrix, so let's use the same matrix A, which is 1 4 minus 5 3, what matrix will you multiply by A to give you the unit matrix? That is, A multiplied by the inverse of A must give us the unit matrix. What is the unit matrix? The unit matrix is, if it's a 2 by 2 matrix, so the unit matrix is going to be 1 0 and 0 1. If it is 3 by 3 matrix, so this is I2. For a 3 by 3 matrix, then it will be 1 0 0 0 1 0 and 0 0 1. That's the unit matrix. Okay. Now, the number, a matrix that you multiply, okay, by a given matrix that will give the unit matrix or identity matrix is the inverse of the matrix. So how do you find the inverse of A? If you want to do this by hand, it's a long process, but in Python it's very, very easy. So we can say print the inverse of A, or let's just say inv A, inverse A equals inv of A. So that if we print A times the inverse, so A print dot A comma inv A, we should get what? We should get the identity matrix. Okay, we should get the identity matrix. So which is what we got? 1, okay, 0, this is 0 then 0, then 1. Okay, this is a very, very small number. So I mean, so when you in some computers, or some computers, it will give you 0 straight, while on some computers, even if you get 2 times 10 to the minus 100, it will still write minus 100, but that is 0. Okay, so that is about the inverse of it. Let's print the inverse as well. So print the inverse of A is inv A. The inverse of A is inv. So this is the inverse of A. So from here up to this point. Okay, let me see. Okay, so this is the inverse of A. Okay, that's the inverse of A. Okay, so the next is eigenvalues and eigenvectors. Eigenvalues and eigenvectors. So what are eigenvalues? So in quantum mechanics we encounter this a lot. In fact, you can solve the Schrödinger equation using eigenvalue approach. Okay, so how do you find the eigenvalue of a matrix? How do you find the eigenvalues of the eigenvalues of a matrix? So let's take matrix A, 1 4 minus 5, or let's take another matrix. So let's consider the matrix B equals 6 1 5 2. So how do we find the eigenvalue of B? So to find the eigenvalue of B, what we do is we find the determinant of B minus lambda multiplied by the unit matrix, then you equate it to 0. So this lambda will now be the what? This lambda will be the eigenvalues. So the eigenvalues are the values of this lambda. If you have a 2 by 2 matrix like this, you're going to get 2 eigenvalues. If you have a 3 by 3 matrix, you're going to get 3 eigenvalues. So in this case, this is a 2 by 2 matrix, so we're going to get 2 values of lambda. So this will now be the determinant of B. What is B? Is 6, 1, 5, 2 minus lambda multiplied by the identity matrix. Is in this case, it's going to be 2 by 2 as well. So that will be 1, 0, 0, 1. Then equals to 0. Then you now say 6, 1, 5, 2 minus lambda times 1, lambda times 0, 0, 0, lambda equals 0. Then you have 6 minus lambda, 6 minus lambda, 1 minus 0, which is 1, 5 minus 0, which is 5, 2 minus lambda, 2 minus lambda equals 0. You now find the determinant. You multiply this by this minus this by this. So that will be 6 minus lambda into bracket 2 minus lambda, then minus 1 times 5, 1 times 5. Then you equate it to 0. 6 times 2, 12. 6 times minus lambda, minus 6 lambda, another minus 2 lambda, that will be minus 8 lambda, minus times minus plus lambda squared minus 5 times 1, 5 equals 0. And you can write this properly as lambda squared minus 8 lambda, 12 minus 5 plus, minus 5, is this 12 minus 7 equals 0. So, and what solves this? So you have lambda minus 7, then lambda minus 1, yeah. So minus times minus 7 times minus 1, that's plus 7, minus 7 minus 1 minus 8, so equals 0. So that your lambda is 7 and 1. So these are the two values, because I told you if you have a 2 by 2 matrix, you're going to get 2 eigenvalues. So if you have a 3 by 3 matrix, you're going to get 3 eigenvalues. So the answers here are 7 and 1. So how do we implement this in Python? How do we find the eigenvalues and the eigenvalues of a matrix in Python? So here we have 6, 1, 5, 2. So let's use the matrix B. Let me comment all this. So let's, Ctrl Z. So let's say B equals matrix first row, second row. So we have what? 6, 1, 5, 2. 6, 1, 5, 2. Okay, so we want to find the eigenvalues. So we import the eigenvalues from linear algebra as well. So we say from numpy.linalgebra import EIG. So this EIG actually contains both eigenvalues and eigenvectors. Okay, you can also calculate the eigenvectors of this matrix. It's a long process, even for a 2 by 2 matrix, let alone a 3 by 3 matrix. Okay, but if you have Python, so you can just say eigenval, comma EV equals EIG B. Okay, so this EIGB returns both the eigenvalues and eigenvectors, but in this case we need only the eigenvalues. So we say print the eigenvalues are, so eigenval. So the eigenvalues are 7 and 1. Okay, 7 and 1. So that's how you find eigenvalues, and the eigenvectors are this EV. So you can also print the eigenvectors are EV. So the eigenvalues, let me use so the eigenvalues are 7 and 1, and these are the eigenvectors. Okay, so that's how you find eigenvalues and eigenvectors in Python. Okay, all right, so next, some applications of this. So you can use this matrix approach to solve a system of linear equations. Okay, so the first term of linear equation we solve here is 4x plus 3y. 4x plus 3y equals 20. Then minus 5x plus 9y equals 26. So how do we use this how do we implement this in Python? So what you do is you first create your okay, let me write 4x plus 3y equals 20. This is equation 1. And minus 5x plus 9y equals 26. I think, let me check again. 4x plus 3y equals 20 minus 5x plus 9y equals 26. So what you do is you convert this to matrix form. So this x and y, write them as vectors, x, y. Then you now have this big matrix here. This 4 will be here, this 3 will be here, this minus 5 will be here, and 9 will be here. So you have 4, 3 minus 5, 9. 4, 3 minus 5, 9. X, y, x, y. Then equals 20, 26, 20, 26. Okay, so you now say, if you want to get this xy, let's denote this xy by capital letter X. Okay, it will now be, let me denote this by M, this by X, and this by Y. So if you want to get this X, which will tell us the values of X and Y, it will be X equals the inverse of minus 1 multiplied by Y. So you can do this, you can write a code to do this. Okay, you find the inverse of M, then you multiply it by Y. But Python already has a function for that. The function is solve. So if you just say solve M comma Y, Python will give you the answers. So let's implement this in Python. So our matrix, so our M is 4, 3 minus 5, 9. Okay, so our M, so let me comment this. So we have our M, which is matrix. So our M is 4, 3 minus 5, 9. 4, 3 minus 5, 9. That's our M. Then our our Y is 20, 26. Y is matrix 20, 26, because it's a vector. So our X, so get our X, we can just say from numpy dot linear algebra import solve. We can do that. So we can say X equals solve M comma what comma Y. So then we'll say print X. So to give us the values of X, of small letter X and Y. So small letter X is 2 and small letter Y is what? Is 4. And you can check. Please, I strongly recommend that you check your answers. The answer that we got is that X is 2 and Y is 4. So if you put X is 2 here, 4 times 2, 8. 8 plus 3 times 4, 12. 8 plus 12, 20. So always check if the answers that you have gotten are correct. Okay, so this answer is correct. Now, the second way that you can get this solution, okay, this is using solve, which is a built-in function. Okay, you can also do it yourself. You can, the way I explained here, you find the inverse of M, then you multiply it by Y. Okay, so you can say print Yahya solution equals, okay, so dot, that is, you multiply the inverse of M by Y. Okay, inverse of M by what? By Y. Oh, have we not imported inverse? Okay, so let's say inverse. So you get the same thing. Yahya solution 2, 4. It's the same thing. Okay, so this is about solving a system of equations in Python. So you have these 3 system of equations. So write a Python code to solve these three systems of equations. So that will be your assignment. Okay. All right. So see you next time.